Thank you. So my expectations going into this talk were last talk of the day, threat modeling, not a very glamorous topic. Probably not going to have too many people in the room. No pressure. So let's get started nevertheless. So first of all, thanks for having me, OWASP. This is my third AppSecUSA, so I'm very happy to be here. I'm very happy to be sharing some of this with all of you. Just a quick intro. My name is Abhay. I run a company called V45. We are in application security. A lot of my work over the last 2 or 3 years has been around automation of application security, DevSecOps, trying to see if we can move the velocity of product development faster. That's what I'm sure a lot of you in this room are doing as well. I'm sure a lot of you are striving to do as well. So that's also been a major area of focus for me. We've developed a product around correlation that I've architected, and a lot of other initiatives. I do a lot of training and speaking as well. Today's session is essentially this. We're going to talk about threat modeling, and I'm very glad to see that a lot of focus in this conference has been given to threat modeling. A lot of speakers, the speaker just before mine was talking about threat modeling, which is great. I'm glad that it's getting its day in the sun. So some issues that I see with threat modeling, again, this is a personal opinion. It may not be an opinion you share. And some things that I have and my team has done to kind of move this forward a little bit on our part. So we just wanted to talk about this new I wouldn't say it's a product, it's more a framework that we've built and open sourced. So let's talk about this. First of all, I have some thanks to give to a lot of folks. These are some of the folks who have really inspired a lot of this, the framework itself and the talk itself. So a lot of this has come from standing on the shoulder of giants, so to speak. So I'm really thankful to all of these folks for their effort in helping me out in this process. Again, before I start, I just want to say that this is not the only way to do things in threat modeling. That's one thing I want to make clear. This is not the best way. This is not the only way. This is just one way. This is not something that I'm expecting everybody to do, but I'm just giving you an idea, and maybe you can take it and do something more with it. It's always nice to see that happening. So I just wanted to put it out there that this is not a hard and fast best way of doing things. I also have a demo. I thought of going with live demos, but then I realized that we don't have too much time, and I decided to record it. But nevertheless, things can always go wrong even in the recording. So pray for me, please. Right, so let me get to this. Current problems that I see with threat modeling, and I'm sure some of you share some of these opinions that I have. One is threat modeling is done today as a policy document, right? I was dealing with, I do a lot of consulting with customers, and one of the customers I spoke to said, hey, this is our threat modeling document, and it was a 350-page document. Now, I'm sure nobody on their team has read that document. I didn't read that document, neither had the security contact at that organization read that document. Nobody knew what it was about. It had a lot of beautiful graphs, had a lot of beautiful diagrams, and that was, I mean, yeah, I'm sure it had some threats too, but I'm sure nobody read that document. It was a pretty large, pretty verbose set of documents that they provided as threat models, right? Today we are in a CI/CD world, right? We're moving fast. We have continuous delivery, continuous deployments. We have continuous integration. Everything is pretty much continuous all the time, right? So in a continuous state of affairs, if you do threat modeling once a year or once in 3 months, or once in 3 months is like really fast for a lot of organizations. They're moving really fast, but their threat modeling is done once a year, or sometimes once in 2 years. It's done as a very ad hoc process. And unfortunately, threat modeling is not able to keep up with this. There's no real way for anyone to keep up with this process simply because it's just moving too fast. Applications are being changed too quickly, and threat models are being written for them maybe 15 versions ago, right? That's a huge problem. And as a result of this, what tends to happen that you produce high-level threat models, right? You tend to produce like very, very basic threats. You tend to model very basic threats. And as a result, it's threats that everybody understands. Like, send data transmissions with encryption. I mean, yes, all of us understand that. It's not a big deal. It's not something extremely new. It's not really something that is solving a huge problem. It's just a very generic, high-level statement. A lot of this activity, a lot of these practices have engendered this problem where we have very high-level threat models, and we end up boiling an ocean, right? We take the entire system in its entirety, and we then try and threat model that system. Imagine threat modeling an online banking system. It's huge. It has so many moving parts. It's got so many APIs. It's got so many different functionalities. You are ending up boiling an ocean, and then you make this. And it goes back to the whole massive documents, not being able to keep up with DevOps, or not being able to keep up with your releases, right? What's worse, it's not undertaken at the beginning of the project. It's usually not updated at all. It's not integrated with your SDLC. It's not integrated with your user stories. It's not integrated with any part of your development processes at all. And there's no, most of the time it's not even linked. It's just done ad hoc a lot of times. And a lot of times I see this, right? A lot of threat modeling is all about diagrams. I see a lot of threat modelers focusing extensively on diagrams a lot. They seem to love Visio a lot. And that's my problem. I'm like, why are you focusing so much on diagramming stuff when you can actually get to the threats, when you should be getting to the threats? Whereas they're putting in these trust boundaries, and they're saying, oh, this input goes to this, and I need to get that really right, and they're we shapes, and that ends up wasting a lot of time, right? And unfortunately, I found that to be a real painful part of threat modeling myself. So we decided to take a few steps to solve some of these challenges. But yet we say this: every DevOps process or engineering process has to start with threat modeling, right? We say this, but then when we start to think about threat modeling in DevOps, we decide to take the exit and just go in for a huge set of bad security decisions. It happens all the time. This is something that we see happening all the time. And as a result of this, there is really no visibility with engineering and business, right? Engineers don't know anything about threat modeling. They don't care about threat modeling. And we constantly complain that they don't. There is no visibility because we have not given them a lot of this visibility, right? So there is not much visibility with engineering and management. However, if you look at the benefits of a threat model, you would see that they are massive, right? You can use a threat model for your dynamic scanning. You can use a threat model to create your SAST rules or model your SAST rules. You can create your threat modeling for tabletop exercises. You can actually use threat modeling for every aspect of your security, application security process, or even enterprise security process. You can really go deep with the way you do or the way you apply threat modeling results or threat modeling outputs. So this is something that, unfortunately, while a lot of us in this room, I'm sure, see this, we don't really, or we are not able to do much about this when it comes to application security within our own organization. So that's what we've tried to solve. We've tried to move the baton a little bit further with this framework, right? So if you look at security in DevOps, and this is typically what you see in DevSecOps, so to speak, right? The term, I'm ambiguous about that term, but nevertheless, DevSecOps, the most common term. You would see that you have different security activities that you're doing across the cycle or the pipeline, right? And if you see how threat modeling applies to it, it literally applies across that, right? Now, if I am able to identify that this business logic flaw is going to hose me later, I'm going to be able to put this into my DAST checks, or I'm going to be able to put this into my penetration testing checks, or I can tell my pen testers, hey, I want you to focus on authorization testing because this feature has a huge amount of impetus in terms of authorization. Or I can write SAST rules to say that, you know what, you need to make sure that every time you call this function, you need to do an authorization check. So all of these can be derived from threat models. All of these, a lot of these can be derived. I'm not saying all of these, but definitely a lot of these inputs can be derived from good threat modeling. And unfortunately, since we don't do that, we kind of lose out on the goodness of threat modeling at large. On the other hand, we are seeing this, right? Spec-based systems. I call them spec-based systems, but you see stuff like Kubernetes, you see stuff like Meso, so you see Docker, or you see any of these things, or any of these infrastructure as code elements, you see that all of these are, you define a spec, you run the spec, and that specification essentially goes and orchestrates a bunch of things for you. It deploys your apps, it deploys secrets, it deploys databases. All of these things are done via spec-based systems, right? Where you have YAMLs and you write a YAML file and you deploy this, and that YAML file talks to an application that does all of this stuff. Literally everything that we know and cherish in today's DevOps environments are spec-based systems. Kubernetes, Ansible, the serverless stack, Terraform, all of these, CloudFormation, what have you. These are all systems where you write as code spec, right? You write as code spec, you write a YAML spec or whatever other DSL that they have, you write a spec in that particular language, you deploy it, and that would essentially do the entire orchestration for you. That's what's happening in most of these systems today in the DevOps world today. So we kind of wanted to merge these two concepts. We wanted to merge these two concepts, and we figured out that for us, threat models are essentially playbooks, right? If you write a good threat model, it's a playbook for your application security. It's like writing out a list of plays and executing those plays for your application security is what we believed in. And it also helps with collaboration. Right now, threat modeling is done in silos. There's the security team that may not understand business requirements, that may not understand technical challenges, that is writing threat models. If we can make it more collaborative, we obviously win that process. We also want to make this iterative, right? We don't want to boil the ocean. We don't want to threat model a massive system. And most of us are dealing with massive systems. We want to keep it small. We want to keep it feature by feature. And we want to keep it iterative. We need to make it manageable. So the idea essentially is this, right? So the idea is we wanted to combine the simplicity of YAML-based spec systems like Kubernetes or serverless or whatever, or Ansible or what have you. We wanted to combine this with application security automation, and we wanted to bring threat modeling into that mix, right? We were already doing the two of these, but adding threat modeling, we felt really added that, that jolt to this entire process. It really helped out a lot. So, which is why we created Threat Playbook, right? Now, Threat Playbook is an open source framework, which you can find. I'll share the link at the end on GitHub. So it's available on GitHub. You can fork it. You can use it yourselves. You can let us know. You can contribute. There's a lot you can do with it. So Threat Playbook essentially focuses on this process, right? So you have a user story, which I'm sure all of you understand what that is, a user story or a functionality statement of sorts. Now that should be linked to an abuser story, right? An abuser story is just a way of us expressing how that user story or that functionality can go wrong, okay? Then we write our actual threat model, which is our threat scenario, which is how can that abuser story come to life, right? Let us say, as an attacker, I want to be able to gain access to the administrator's account and perform and create dummy users or create bogus transactions, right? Now, that is an abuser story, right? That abuser story comes to life in the form of SQL injection or CSRF or what have you. All of these different, the OWASP top 10s and more of the world, right? Where we see that these technical scenarios actually come to life and how we can make it come to life based on that particular abuser story, right? That's what we want to go with. Once we have an abuser story, we also have a security test case or a threat scenario. We also have a security test case. So let us say, I say, as an attacker, I want to be able to compromise a user's account so that I can create bogus transactions. That is the abuser story, right? It's high level. Everybody understands, including business, developers, your security team, everybody understands that statement. However, as you drill down, hey, how can that story actually come to life? How can that abuser story come to life? You can say that, oh, we can do SQL injections against it. You can do CSRF against the administrator's account. You can probably exploit a weak password. You can do all of these different things, right? You can do all of these different various attacks. You can then write out your security test cases, right? To say that, okay, you need to ensure that you test for SQL injection, look for it in SAST, DAST, SCA. You need to test for weak passwords. You need to make sure that the password policy is up to par. You need to test for CSRF, make sure that there is tokens or whatever else you're using to protect against CSRF. You can write out security test cases, and then you also have the mitigation as to how you can actually mitigate against this particular set of threat scenarios that you have. So essentially, threat modeling for me is this, right? You systematically drill down into what really affects you based on your risk and identify test cases and mitigations for it. And this you can use not only as an engineering team, but I've used this as a pen tester. right? As a pen tester, if I want to drill down to what I need to be looking for the most, I go with this approach. Hey, which is the secret sauce, or which is the the most critical functionality in that application? Figure out what kind of threats it can be potentially subjected to, and start chasing after that in my pen test. Right? I can start prioritizing my pen test a whole lot more if I use this simple approach to doing that. Right? So our approach is essentially this. So you build your threat model with user stories, you add abuser stories to those user stories, you add threat scenarios to those abuser stories, you link those with security test cases, which would run automation for you, and this would essentially be your DevOps, your security in DevOps. So a lot of what we are doing is taking the entire threat modeling piece and using that to run an entire DevOps pipeline for you, or a security pipeline, so to speak. Not a DevOps pipeline, but definitely a security set of tests for you. So what we are, that is our aim, and that's what we have done with this. And for this, we've used a framework called Robot Framework. How many of you have heard of Robot Framework? Now, if you're in the QA world, this is a lot more well-known, but as a security folks, we may not have known of it. Robot Framework is a simple, it's like BDD. How many of you have heard of BDD? So BDD is a more common test framework. Now, Robot Framework is a slightly newer framework, but it's similar to BDD. The only difference is that in BDD, you have this given, when, then syntax. Robot Framework is syntax-free. You can write English natural language statements, and that becomes a test case, right? So what we've used is Robot Frameworks, where Robot Framework scripts, where you can use the core threat playbook robot library, and we have another bunch of libraries that we've written for ZAP, for different SAST and SCA tools and DAS tools, and so many other tools that we've written for. You can invoke those automation parameters at strategic points, and you can build out your entire security pipeline, right? So let me just quickly show you what I mean by that. Let me just quickly get to the demo part of this. So, yeah. So this is essentially our threat playbook configuration. Oops, I think I need to. I'm just going to mirror displays. Sorry about that. Yeah. So this is essentially how you write stuff in threat playbook, right? So this is an example of a threat model of a particular feature, right? So this is entirely written in YAML, right? So this feature is called login, and this has a user story. As an employee of the organization, I would like to log in. Actually, let me just show you something with more business logic type of impact, right? So this is a feature called create expense or manage expense. So this application that we're modeling is a corporate expense management app, where you can upload expenses that you've incurred during travel or whatever, and then you can get reimbursed for those expenses. So this feature essentially is one of the manage expense user story, right? As a user, I'm able to upload expenses within a project limit that have been incurred to me for processing payment by my manager, so that I can get reimbursed. So I can upload an expense, and once the manager approves it, I can get reimbursed. So that is the user story, or that is the functionality statement that I'm making, right? And then I can write out the abuse cases or the abuser stories, right? What could potentially happen? How could this user story go bad, right? So you could say, as a malicious user, I will upload or manipulate expense management process to get a larger or bogus expenses into the system, right? So I could say that I would try and exploit something in the system to get bogus expenses or larger than limit expenses into the system and get approved for it. So how could I do that? I could do SQL injections. I could compromise my manager's password. I could steal my manager's authentication token through a cross-site scripting attack. I could do all of these different scenarios to make that happen, right? I have all of these different threat scenarios for that particular abuser story. So you can see that I've captured all of this. Now, the cool thing with Threat Playbook is that we've already given you a list of canned vulnerabilities or scenarios that you can look at. So we already have some of the OWASP top 10 given to you in the spec. So you don't really need to write out stuff the whole time. In the new version of Threat Playbook, you just have to call that name and say, hey, this is SQL injection, and it will automatically understand that it's SQL injection and figure out that particular threat, right? Now, all of this is how you model that particular. So this is just an example of that model. Oh, sorry about that. I'm not able to. Oh. Yeah, I mean, I wanted to open in that so that it's easy to see. But anyway, that's fine. I wanted the entire directory structure. Sorry about that. Anyway, so in this case, what we're doing is we're saying that SQL injection, you can just call that particular thing, saying you can call it from the repository that we already have and say, hey, this is SQL injection, this is highest severity or most critical severity flaw, and this is how you should capture this. So what we're doing here is we can model feature by feature in YAML files. And you can commit this to a GitHub repo or whatever it is. So every single time you're adding a new feature, you are also adding to that threat model very quickly by modeling with a YAML or a simple, easy to use kind of a framework. Now, all of this really comes down to this particular script. And this is where the integration with CI/CD really happens, right? Try and, man. When things go wrong, right? Yeah. Now, this is really what makes Threat Playbook the whole a CI/CD compliant or CI/CD friendly tool. Now, this is a robot script, right? Now, this robot script essentially has a bunch of test cases. So we are setting up test cases, and you can see the writing of these test cases is not that complicated. And what we're doing in this test case script is running an entire security testing pipeline. We're saying, hey, these are the entities that you're using to create your diagram for your application. You load your threat models. You create your target. So let us say you're running a SAST and a DAST. So in this case, what we're doing is we're going to run a SAST scan. This is a Node.js application. We're going to run a SAST scan. We're going to run NPM audit to identify source composition issues with that node application. Then we are going to fire up ZAP, and then we're going to proxy all of the web service requests, which is going to authenticate to that particular application, and then generate those inputs for ZAP to work. Once that is done, it is going to destroy the ZAP session, write all of the results. And one of the things that Threat Playbook does after all of this is link the results with the threat models. So let us say your threat model says SQL injection and ZAP finds a SQL injection. Threat Playbook tries to correlate and say, hey, you identified this as a critical finding, and this is in my threat model, so this is obviously something of high priority for you. So Threat Playbook does that. It's a CLI tool. All of this is just CLI. There's no server or anything like that, right? So let me just run the video of the demo, and you can see what's happening. All I need to do is call that script. It runs all of these different test cases. You can see that it's running the Node.js scanner. It's running NPM audit against the code base. So this thing, what it does is it pulls from GitHub, runs the Node.js scanner, runs the NPM audit results, NPM audit against the package.json file. It does an SSL test against a running version of that particular application. And then once it is done, it fires up ZAP. And you'll see ZAP firing up soon. So ZAP fires up. The authenticated web service, so it authenticates to the web service with ZAP as a proxy. And I'm just going to skip through a little bit because you've all seen ZAP. So ZAP runs. You can see that it authenticates to the web service with ZAP as the proxy. ZAP identifies whatever issues it does. I've just fast forwarded the whole ZAP scanning process. I didn't want to show you a huge scan. And that's it. And it generates all of the diagrams. So one of the things I hated doing was writing diagrams, right? This generates diagrams for you. So this is something that we have done quite well with Threat Playbook. So let me just show you the kind of reports it gives you. So all of these are stored in a results directory, which is part of that same project. So Threat Playbook creates some boilerplate code for you. So it generates the cases file, it generates the security test cases, it generates a YAML file for all of that. So you just have to go and start writing stuff, right? So let's look at the report that it finally generates, okay? So like I said, it generates your process flow diagram based on the entities that you've defined. The next thing it does is that it gives you your threat models along with your linked security test cases. So it gives you the the user story, the abuser story, the threat models linked, the threat scenarios linked to that, and the tests, the security test cases that are linked to that particular threat scenario. You can see that the test cases, I have written a bunch of test cases here. These are again from the repository, so you don't need to write a lot of these. You can actually just use the repository's test cases if you're using some generic vulnerabilities, or you can write stuff in line. Then you can actually get your vulnerability assessment results as well, because you can see that we ran the SAST, we ran the source composition analysis, we ran DAST. You can actually get your entire vulnerability assessment results coming up here. And if that vulnerability result has a CWE, it would actually correlate with your threat result. So let me just show you what I'm talking about here. You can see this, right? SQL injection that has been identified by ZAP actually has a linked threat model that says that, hey, you said that SQL injection was a big threat model for you or a threat scenario for you. And this is where SQL injection has been identified in your existing threat model. And we've tried to link it up for you. So obviously, this is at a higher plane in terms of the kind of vulnerabilities that you have. So it allows you to link the threat model or the threat scenario with your vulnerability assessment results, with your vulnerability findings. So you can actually run this in Jenkins, you can run this ad hoc, you can run this as a script anywhere. Robot is quite friendly, and as you can see, it's not very difficult to write. So keeping in mind, you know, that security folks cannot write, a lot of security folks may not code. This becomes very easy. You can write security test cases in natural language syntax and get it done. One of the other things that Threat Playbook also does is generate something called threat maps, right? So for every feature that you threat model within Threat Playbook, it generates the threat map, which gives you a graphical representation of the user story, the abuser story, the linked threat models, and the test cases for those threat models, right? So this is quite a complex diagram, as you can see. Again, this is entirely generated. I wanted to make sure that I never drew another diagram in my process ever, so I decided to do everything generation. So everything gets generated from the YAML spec that you define. All you have to do is define the YAML spec, and it generates all of these different artifacts for you, making it hopefully easier for you to understand and consume your threat model. Right, so coming back to so who can use it? Obviously, as an engineering team, we are hoping that you can use Threat Playbook for your iterative threat modeling process. Since you're going to be threat modeling feature by feature, you can use something like this to run iterative threat models. We use it a lot in our pen testing as well. So when you are pen testing, you can have a lot of features listed out and what you want to focus on in each of these features. You can write it out in YAML, and you can even give it to your client. So tomorrow your client asks, what is the coverage of your penetration test? This is a good way of establishing coverage, right? We're saying that you can actually cover a whole lot with this particular type of automation that you have. So what kind of problems and questions we are hoping this solves? Of course, it's still at its infancy. This is a 3-month-old project. We're going to see a lot more development happening. and hopefully a lot more contribution from the community at large. So what's the coverage of your security test? I've been asked this question a lot of times. I'm sure a lot of you have been asked the same question, right? What is the coverage? How much does your security test cover? And it's different from functionality, right? Functionality, you have a list of defined functionalities. Whereas, in my opinion, a security test coverage is based on its threat model, right? And if you can say that, hey, look, this is my threat model, and this is what I have covered as part of that threat model, that is definitely a bigger success factor for me than a lot of other types of coverage, right? Or, do you have threats for this particular feature? Yes, you can just write out another YAML file for that particular feature, update the YAML file, put it in GitHub, commit back and forth, and you actually have an iterative updated threat model for the feature and for your application at large, right? So you have our iterative feature, and this stores results in Mongo, so you can actually use that for persistence and also use that if you want to continue the whole process. Or you can just write YAML and just process YAML in some way. That's something you can do as well, right? The other thing that it hopefully answers is, hey, you have security test cases. What test cases are you running? A lot of times, we want to know what we are running in either our CI/CD process or what our pen testers are running in terms of security test cases. Threat playbook allows you to capture these test cases and also automate that entire test case and integrate that automation in your CI/CD. So it kind of has a broad set of goals that we're trying to achieve. So our objective for this, again, the reason why we chose robot framework, natural language syntax, easy to develop API, modular reporting comes out of the box. You have this nice little HTML reporting module comes out of the box. It also has a lot of support for existing test automation tools, Selenium, Appium, Calabash. The previous speaker mentioned Calabash. This has Calabash support built out of the box for mobile testing as well. So you have a lot of third-party libraries around it. It's a pretty up-and-coming test framework, and that's why we use it. We have robot dependencies created for all of these different tools, and it's available on GitHub, so you can use it. Please feel free to use all of these, except Burp Suite, because they changed the licensing on us 2 weeks ago. So that's not in circulation anymore. But if you're using any of these other tools, we have integrations for these already. And you can use robot framework integrations for any of this, as you can see. The cloud ones are still being developed, by the way. So with this, the future, what we want to do with this is, we want to make this the Kubernetes of application security, right? We want this to be a nice little orchestrator that can orchestrate threat models, automation, and all of the different things that you would want from an application security program. I'm adding a CLI for this. It's release 1.2 is coming up soon. I'm going to add a CLI and make it much easier. Trust boundaries, all of us love trust boundaries. I want to add some functionality around that, especially for the diagramming part of it and for people who want to diagram a lot. A better diagramming API, right now I'm using Mermaid.js, not that great. I want to use something better moving forward. Contributors welcome, of course. It's in Python. Please feel free to contribute if you'd like. This is the URL. That's my Twitter information. I constantly share a lot of information on Twitter and LinkedIn. So please follow our blog. So this is me. Thank you so much, and I hope this was beneficial. Thanks for being a great audience. Thank you.